Wow, so many people. It's making me nervous. Good thing that presentation is done half-half in AI. And speaking of AI, probably a lot of you thought that it might take our jobs in the next decade or less. But I guess we will figure that out in a couple of next slides. And speaking of AIs, we'll talk about Copilot. Um, Okay, it works now. We'll talk about Copilot, tool that is changing the game for us devs. And technically speaking, Copilot is a set of GPT-4 tools. They are developed by Microsoft and designed to enhance productivity by integrating generative pre-trained language models with Microsoft suite of tools. It's a Microsoft version of ChatGPT, serving as an everyday AI companion. But now we're speaking about GitHub Copilot, as it's specifically designed for developers. It is an AI-driven programming model that enhances the code writing and just speeds it up. It suggests relevant code completions and can generate entire algorithms and functions in real time. It basically is a virtual AI assistant that speeds up the whole development process. And it's available, for instance, for Visual Studio Code and Visual Studio. While most of Microsoft Copilot tools are generally free to use, GitHub Copilot has a free trial, after which a paid subscription is required to continue the usage. Of course, there are plenty of notable alternatives which have completely free plan, like Codium, like Tab9, like Leplit. However, GitHub's Copilot popularity comes from its extensive user base and strong community. As we know, there are thousands of open source projects, and it's being trained on a lot of them, and it's constantly being updated based on user feedback, which is making it a reliable tool, and it just has access to all of these frameworks and languages. And it can tackle easily complex problems, saving you both time and effort. It assists in code writing, in debugging, and just explaining what's happening in your code. You can easily start a new project and just ask Copilot, OK, tell me what's happening here. And it will assist there. And it's evolving with you. It's learning your style, your coding style, your project. So with time, it will just give you better answers and better influence on your project. And also, it supports multiple languages and frameworks, making it a versatile tool for developers who work on more than one language, as probably a lot of you. It supports C#, Java, JavaScript, TypeScript, CSS, HTML, pretty much everything nowadays which is popular. And now you probably think that Microsoft is paying me to give you this lecture. They are not. I'm not here to give you the hard sell on Copilot. Sure, it has its advantages, just like any other AI completion tool. But also it has significant drawbacks like legal, ethical, and code quality concerns even. The data it was trained on could lead to potential biases in the future, as it could suggest you some ideas or answers which might not be the best fit for you, or give you some frameworks which won't work for you at all. As Copilot is collecting telemetry data, this is raising privacy concerns of its own if it's giving something which it shouldn't. Also, it was trained on open source projects, and this open source project might require some legals or notices in the projects which are using it. And if Copilot forgets to generate that, or you don't know that, this will raise some legal concerns of its own. And of course, it's not always up to date, so it might lack some recent libraries or just frameworks, and will give you an answer which is outdated. And of course, there is the code quality problems of its own. Even GitHub admits that not always the answers are a working one, and the developer should pay really attention to what is being generated in just order to not break the whole project. And OpenAI acknowledges that only 30% of the time the answers are working one and accepted by the end user, but this is due to limitation of the language models, not only Copilot. Now that we've covered the groundwork, let's dive deeper into the more practical sides of Copilot, and let's see how we can easily start using it. For instance, we have Visual Studio Code. We need to have extensions. We can just easily install Copilot, and we need to go to GitHub in the settings panel and enable Copilot. Here, again, I want to mention that it has a free trial after which you need to pay to continue the usage. And with that, we can start copiloting. And now you see how easily I can type without a keyboard. Here we'll examine how Copilot assists in code writing in Visual Studio Code. We have a user service which has real email sending logic. We are saving data in Azure DB. We require robust validations, detailed commenting, and unit tests for code coverage over the whole user service. And by simply specifying our exact needs in the prompt, Copilot will do the rest easily, as we can see, and generate a working solution quickly. Here is also worth mentioning how effortlessly Copilot is integrating with other Microsoft services, such as Azure Service, as we see in the Azure DB, because of its deep integration inside the Microsoft ecosystem. And we have here unit test generation. Remember them. In addition to it, we have a chat interface, which expands to everything. Here you can ask questions, what's happening in your code. If you have a bug, it can generate code snippets or just explanation what's happening. And it just expands the whole context. It's available also as an extension for most of the popular IDEs like Visual Studio Code. We saw how Copilot generates unit tests in the prompt for the specific file. With the chat interface, we can have in mind the whole context of the project, if you want, and it can generate more meaningful unit test cases. So now we know what Copilot is. And we understand that there is a need to integrate such an AI-powered tools in our developers' work life. And understanding that, we at Scalefocus embark on an internal review to critically assess Copilot's impact in coding efficiency in developer experience with their programming IDE. And the goal of this research was to uncover the true effectiveness of Copilot and provide an objective analysis of its reported benefits and limitations. And building on these objectives, our research was guided by specific key points. First, we observed how Copilot was affecting the user experience with its usage. Another crucial area was to measure how much lines of code were written per specific amount of time with Copilot versus without the usage. Another crucial area was just to measure the total lines of code written with Copilot versus without Copilot. We were also measuring the impact in our code base, meaning how much of the code generated by Copilot was making it to the final product, to the master branch. And finally, but probably most importantly, we were reviewing if Copilot's answers were a working one, and if they introduced bugs, vulnerabilities, code duplications, and just slowing down the whole system, the whole processes. And of course, we aim to uncover if it's fit for our development needs. And in order to have a thorough and unbiased review, we establish clear criteria and methodologies to ensure we can measure it as much as possible, as close as possible to real-world project scenarios. The whole research started with 2 initial sprints. In it, we didn't use Copilot in order to gather some data which were used as a baseline. After it, we continued with 6 additional sprints. And we were using Copilot here, of course. Here it's worth mentioning that one sprint in our research was 2 weeks, and the whole research was carried out in 2 different projects. Each project had a front-end and a back-end team. And so we aim for a variety of technologies, frameworks, and use cases just to be as thorough as possible. And the developers were asked to fill a detailed evaluation forms, after which completed task and completed sprint to gather that needed data. And also we leveraged SonarQube, a static code analysis tool, to review the quality of these lines of code to ensure they are up to standards. And we carried this data weekly session meetings to see how the progress was working on and just to have some tips and tricks. So moving forward with the interesting things. First, there is the Net Promoter Score, or NPS, which provides a high-level overview of the developer satisfaction with the usage of Copilot. Here I have 2 main, oops, I spoil you the next one. We have 2 main areas. We have different task types, and on the right side, we have new feature tasks and bug fixes. And on the left side, we have how the user experience is changing based on different task sizes. We have a small one. In our research, a small task was around 1 or 2 days to be completed. We have a medium-sized one, which took around 1 week, and large tasks, which took more than 1 week, I guess. And here, across all task sizes and task types, we can see high-level overall satisfaction with the developers of using Copilot. And diving deeper into this user experience, let's examine how the user satisfaction was changing depending on the task size measured in lines of code. Here, interestingly, when the task size was a small one, meaning less lines of code, the overall developer satisfaction was staying low. But as the task size was progressing, the satisfaction of the developer was increasing. And this indicates that the tool is more useful when it can just generate more code. It has bigger impact in the user experience. And here to summarize, if your task is less than 100 lines of code, you probably shouldn't use Copilot at all. If it's 100 or 200 lines, it might not make any impact. But if it's more than 200 lines of code, for sure it will have some positive impact on your experience. Now that we've seen the experience of the developers, let's see how much lines of code and time was affected by Copilot when we are just completing a task. We have 2 main areas here, bug fixes and new feature tasks. When it comes to new features, Copilot is helping us write less code for less time. However, for bug fixes, we're actually writing more code with Copilot. But this doesn't negatively impact the overall time needed to complete the bug. And here, just showcasing that you probably should use Copilot for new feature tasks. Another crucial area is unit testing, especially in the software quality. Here we're examining something maybe strange for you. We're tracking how Copilot is affecting the time needed to write unit tests for different task sizes measured in story points. And here, just to showcase the result, use Copilot to write unit tests for new feature tasks if they are medium size or bigger, and don't use it for bug fixes, as for sure it will slow down your whole development time. And one of my more impactful slides is how much of the code generated by Copilot was actually making it to the final product. And here we'll probably answer the question if Copilot will take our jobs, at least for now. Here, across all task types and task sizes, we can see that approximately 1/5 or 1/6 of the code is actually made from Copilot, generated from Copilot. And this just showcases that at the end, we're writing 80% plus of the whole code. We're still making the huge impact in the code base. It's up to us developers to fine-tune the code, make it working one, and just deliver what is needed. And it's not for Copilot. Here we're seeing how much lines of code were written with Copilot versus without Copilot. And it's really interesting, as with Copilot, we're writing less lines of code. And it's really counterintuitive for a tool that is designed to boost productivity. However, when we thought on that and talk with the developers, we actually figured out that the developers, when they're using Copilot, they're trying to tackle more complex problems, trying to write more sophisticated code, and Copilot is just there to assist with the boilerplate, with the repetitiveness of coding. We've seen the data, how Copilot is affecting the developer, but let's now see how it's affecting the quality of these lines of code in the project structure. Let's put it under SonarQube, a static code analysis tool, which we used after every pull request in our system. Here, first, we have average amount of bugs. And this is more the positive trend. As with Copilot, we gradually are reducing the amount of bugs in the system. However, when it comes to code duplication, oh man, it's increasing them a lot. And this is due to Copilot's main focus is to generate quickly a working solution. And it doesn't having in mind the whole project or generate something of higher quality. And another bad thing which was impacted with Copilot was the amount of vulnerabilities. With Copilot, we actually are introducing a new vulnerability on every 4 pull requests. But on the brighter note, we've seen a gradual reduction in the security hotspots in the system. And for the code smells, we've seen that on average, on every 3 pull requests, we're reducing and just removing one code smell. And these metrics and the metrics before that, we see that they are not game-breaking, they are not game-changer, but they play a pivotal role in just understanding how best we can fit Copilot in our development work and how we can use it to maximize the profit. And if it actually is a working solution for us. And with all the data gathered and insights gathered, for sure we need to acknowledge some of the key concerns which have emerged with the usage of Copilot. First was choosing Copilot for every task and every task size and task type. Our analysis revealed that when we are using it for bug fixes or small new feature tasks, actually we might slow down the whole development process and just reduce the user experience. Another crucial area was over-relying in Copilot to do our job. Sure, it generates a working solution quickly, but it doesn't keep in mind the whole project structure, project architecture, and it can generate a lot of vulnerabilities and bugs if we don't pay attention to it. Of course, there were code quality concerns. As we are not paying attention to what's being generated, we're increasing the duplication. This is slowing the whole project system and performance of the solutions, especially in enterprise solutions where performance is a must. And finally, we were just impacting the readability of the project badly, as it is generating some sophisticated code. It might pose challenges for future maintenance. And here, we can see how Copilot easily can generate a working solution, but with huge redundancy. In this example, we have a simple dog, cat, and bird service. They have similar methods and properties, and they're pretty much doing the same thing. And Copilot would generate quickly a solution which is a working one. But as we will see now, it has huge redundancy, and it just doesn't care about that. And we have now the bird service, which is the same. And finally, let's conclude this presentation by highlighting the best practices, the tips and tricks which you can use to make your Copilot experience beneficial and just optimize your overall experience with Copilot. First, use it for new feature tasks, and especially if they are medium size or bigger, as the two tendencies to generate substantial amount of code and you have more time to work on more meaningful things play a pivotal role in just enhancing the developer's satisfaction. Also, it's worth using scanning tools like SonarCube to ensure that the answers which are generated are a working one and the quality of the code is up to standards. And it's really beneficial to use Copilot to generate substantial amount of unit testing and just detail committing, as it does that really easy, and it has in mind the whole context of the project. And finally, but most importantly, use Copilot as a tool, not a replacement for human judgment. As we saw, it's up to us to finish the project, to do the 80% of the coding. And if we let Copilot does that, probably we will affect the whole project structure badly. And with these tips and tips, we can be sure that we're experiencing the best of Copilot without compromising the project overall efficiency. Wow. I hope you had this presentation useful, and really enjoyed to be here. Thank you, everyone, and yeah. Go on.
Folks, I think we have a few minutes, so we can do a round of questions. Don't be shy. Well, okay.
Hi, really interesting. Can you share some example how you handle cases for one of these concerns that you just mentioned, the duplication of code and the quality of the code?
This one, or yeah.
No, in general, the concern that you mentioned. But yeah, here.
Well, with SonarCube, we found it easy to just figure out what's happening in our code, and we saw easily, for instance, there were a lot of vulnerabilities, meaning we were logging, let's say, sensitive data, or we were just concatenating some connection strings which were something which Copilot is generating to assist with, if we say, increase the readability, but this was creating a vulnerability of its own. So we were just paying attention to this when we were using SonarCube as another tool in our developers, with our developers.
Other questions? I guess no.
In the back, there is one question.
Oh, yeah.
I have a question. So did you make cross-analysis between the level of experience between developers? So, for example, how much code generation helped the juniors versus seniors and vice versa?
Actually not. More of the developers which were in this research were, let's say, the same experience. They are more seniors. We were aiming to uncover how Copilot was affecting the same group of people and not different experience.